So in this section, we're going to be applying Newton's laws. This might be Newton's first law, second law, third law. We might need to use free body diagrams or any combination of those. So what we have in this situation is a contractor pushing a stove across a kitchen floor with a constant velocity. Again, that's a key term that tells us that the net force on this object must be 0. The contractor is exerting a constant horizontal force of 85 newtons forward. Force of gravity is 447 newtons down. And I want a free body diagram and the magnitudes and directions of the remaining forces. So I've only told you some of the forces, we need to determine the rest. So free body diagram, the stove will be a box. What we've been told is that there is a horizontal force of 85 newtons forward. This would be an applied force. We also know that gravity is acting with a force of 447 newtons down. And we need to determine the remaining forces. Well, if gravity is acting down, the stove is sitting on the floor, then we have a normal force acting up. And the normal force must always be equal and opposite to gravity. And the last thing we have, because this stove is moving with a constant velocity, the force of friction must be equal to the applied force, so it must be 85 newtons as well.